Hello Year 11 Extension 1 Mathematics students. Today we're continuing on with the topic of polynomials and we're learning about graphing polynomial functions. So to graph polynomial functions, we factorize the polynomials to find their zeros first. So let's jump into some examples. So for the polynomial px equals x cubed minus x squared minus 5x minus 3, we want to first factorize the polynomial. So to factorize our polynomial, first what we want to do is we want to try factors of our constant. So we try factors of 3. So we have plus or minus 1 and plus or minus 3. So we want to substitute those into our polynomial to see if we get zeros for them. So we're going to try, first we're going to try the polynomial of 1. So like I've said in previous videos when we've done this, if you just get your calculator out and substitute in 1 for x to see if it equals 0. If it does, then write it down. If it doesn't, move on to another number. So when we sub in 1 into the polynomial, we get -8. So this doesn't work. Let's now try -1. So if we sub -1 in where we have an x into our calculator, we get 0. So now I would write it out. So when we sub -1 in for x, we get -1 cubed minus -1 squared minus 5 times -1 minus 3 equals 0. So therefore, x plus 1 is a factor. And now we're going to divide our polynomial by x plus 1. So we have x plus 1 divided by, divide our x cubed minus x squared minus 5x minus 3 by our x plus 1. So when we do that, we go x cubed divided by x gives us x squared. So we write that up there. And then x squared times x is x cubed. X squared times 1 is plus x squared. Then we subtract. So minus 1 x squared divided minus x squared is -2 x squared. And then we bring down our minus 5x. And now we divide our minus 2x squared by x. So we get minus 2x. So minus 2x times x is minus 2x squared. Minus 2 times 1 is minus 2x. Subtract. So minus 2x squared minus -2x squared is 0. And -5x squared minus -2x squared is -3x. Bring down the -3. So -3x divided by x is -3. -3 times x is -3x. And -3 times 1 is -3. Subtract. -3x divided minus -3x is 0. And -3 minus -3 is also 0. So therefore we have x plus 1 times x squared minus 2x minus 3 equals 0. We need to factorize our quadratic here. So we can do that. So x plus 1 and then it will be x minus 3 and x plus 1 equals 0. So we'll have x plus 1 squared times x minus 3 equals 0. So now we want to sketch the graph of the polynomial. So we first want to find our x-intercepts when we sketch our graph. So for our x-intercept, we let y equal 0. So we let our polynomial be equal to 0. But we want to use our factorized version. So we want to use our x plus 1 all squared minus times x minus 3 equals 0. So we're going to say that 0 equals our x plus 1 all squared times our x minus 3 equals 0. So therefore our x-intercept are -1 and +3. And then for our y-intercept, we let our x equal 0, and we can just sub this straight into our original polynomial. So it'll be 0 cubed minus 0 squared minus 5 times 0 minus 3. So that equals -3. So therefore our y-intercept equals -3. So then we're going to sketch what we know, or we're going to plot what we know, sorry. So we know our y-intercept is -3, so -1, -2, -3. So we just have to write our axes on. So 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. I will do my -4 and -1, -2, -3, -4. So now we want to plot our points. So we have a point at an x-intercept at -1, oops, and an x-intercept at 3, and a y-intercept at -3. And then we need to test what happens. So we need to test whether our graph starts up here, or it starts up here, or starts down there even. So we're going to test what happens when x is less than -1. So test x is less than -1. So let x equal -2. So we're going to substitute that in. So when we sub in -2, we get -2 cubed minus -2 squared minus 5 times -2 minus 3. And so let's just chuck that into our calculator real quick. Make sure it's nice and accurate. And so when we do that, we get -5, and -5 is less than 0. So that means our graph starts below our axes. So our graph is going to start like something like this. Okay. Then we want to test what happens between -1 and 3. We sort of can know by looking at our graph that it wants to go through the y and have a y-intercept of -3. So it wants to go through the y-axis at -3. So we can sort of tell that it's going to stay below the x-axis, but we still need to test it. So we're going to test what happens between -1 is less than x is less than 3. So we'll let x equal 0. So when we sub 0 in, we did that up here. So we know that equals -3, which is less than 0. So we were right. It does stay below the x-axis. So it bounces off the point -1, goes through -3, and then up to 3. So it goes through -3, and then goes up to 3. And then we're going to test what happens when x is greater than 3. So test x is greater than 3. So we'll let our x equal 4. So when we sub 4 in, it equals 4 cubed minus 4 squared minus 5 times 4 minus 3. And so we substitute this into our calculator. So 4 cubed minus 4 squared minus 5 times 4 minus 3. And when we do so, we get it equal to 25, which is greater than 0. So it means that our graph goes above the x-axis. So then we just add on our arrows to our graph, and we need to write the polynomial down. So our polynomial is px equals x cubed minus x squared minus 5x minus 3, and that is our sketched graph of our polynomial. So moving on, we now want to talk about the limiting behavior of polynomials. So sometimes we can graph our polynomials by just knowing, by factorizing them and then testing points, or testing what happens to x. But we can also factorize and then just know about the limiting behavior of our polynomials and do our sketch a lot quicker and a lot faster. So for the limiting behavior of polynomials, what does the graph of a polynomial look like for large positive and negative values of x as x approaches plus or negative infinity? So we know that for the graph of a polynomial, so if px has an even degree, the ends of the graph both point in the same direction. So when we have a polynomial of even degree, both our endpoints or our arrows are pointing in the same direction that they started with. We also have that here, our leading coefficient impacts where our starting point is. So for this first graph here, this one here, we have an even degree, and because our leading coefficient is greater than 0, this means that our polynomial is going to start above the x-axis, and it's also going to end above the x-axis. For our second one here, this one, we have that our leading coefficient is less than 0. So this means that our polynomials are both, our start point is going to be, our polynomial is going to start below the x-axis, and it's also going to end below the x-axis. For if a polynomial has an odd degree, then the ends of the graph point in opposite directions. So this graph has an odd degree because the polynomial, the graph points in opposite directions, and this is an odd degree because the polynomial is in odd directions. Also with this, we have that our leading coefficient, so our leading coefficient for an odd degree is that our graph starts, when our coefficient is greater than 0, our graph actually starts below the x-axis, and when our leading coefficient is greater than 0, our polynomial starts above the x-axis. So this one here was even degree, starts and ends in the same direction, leading coefficient greater than 0 or less than 0 states where graph starts coefficient positive or greater than 0 means it starts above the x-axis, and then coefficient negative or less than 0 means it starts below x-axis. Okay, so that is an even degree. Then odd degree. So odd degree starts and ends in opposite directions, leading coefficient is opposite where graph starts. greater than 0 below x-axis, less than 0 above x-axis. Okay, let's have a look at some examples. So we're going to state for each graph if the leading coefficient is positive or negative and the degree of the polynomial is even or odd. So for A, the leading coefficient, is it positive or negative? Well, first, what we need to work out is whether the degree of the polynomial is even or odd. So we need to look at the start and the end points. So the start and the end points are pointing in different directions. So because they're pointing in different directions, it is an odd polynomial. And because it's starting in leading in different directions, or the graph points in opposite directions, this means that the leading coefficient is going to be the opposite of where it's starting. So it means it starts in a positive, but it means that the leading coefficient is actually going to be negative. Looking at B, so again, we need to look at II first. So the points, these end in the same direction. Because they end in the same direction, they're both going down. It means our polynomial is of an even degree. And so because they're both down, this means, if we scroll back up, that our leading coefficient is going to be less than 0, because wherever our polynomial starts, when it's even, that says, whether it's in the positive or the negative, it says what the leading coefficient is. So because it starts in the negative, it means our leading coefficient is also going to be negative. Looking at C, what we have here, again, we need to look at our end points, or the points of our polynomial, and because they're both going pointing up, it means because they're both going in the same direction, we have a polynomial of an even degree. And because they are both in the positive, and because our first one is in the positive and it's even, it means that we have a positive leading coefficient. For D, we have our points of our polynomial are opposite. So because they are opposite, it means that this is odd. So odd opposite, OO. And then because our polynomial is starting in the negative, it means when it's odd, it is the opposite. So it's going to be a positive leading coefficient.